So, as quality professionals, we love principles, frameworks, best practices, guidelines, and occasionally debates about them. So, for decades, test principles have helped shape our profession. But what happens when principles become unquestioned rules? So, our next speaker challenges us to think the way we approach testing philosophy itself. Brijesh Deb is a quality engineer leader with more than 25 years of experience in software testing, AI, and agile transformation, a principal consultant at Infosys and chief enablement officer of the test chart. He is widely known for his systems thinking, ethical perspective, and thought leadership within the global testing community. In this session, we will explore how traditional and modern testing principles are not competing philosophies but complementary tools with whose value depends on the context. So please welcome our next speaker, Brijesh Deb. Over to you, Brijesh.
Thank you, Vamsi. Thank you for the very nice introduction. I hope you can hear me.
Yes, yes, you can
Okay,
continue.
excellent. Let me try sharing my slides. Wow. Okay. Do you see my slides? Do you see my
Yes,
slide?
Brijesh, it's visible. Yeah.
Okay, excellent. All right. Yeah, very nice introduction by Vamsi for the testing principles. Now, very interestingly, I was observing the quiz. The testing principles have been so ingrained into us that they were also in some of the options. I can see Sagar smiling as I talk to him about it. So, this is how ingrained we have got into. And I'm sure that a lot of the audience sitting here is ISTQB certified. There was an ad of ISTQB certification advanced level. So when you are doing your ISTQB certification foundation level, uh, there is a book that is usually used as a reference for foundation level testing, and that was written by none other than Dorothy Graham, Eric Van Vinendal, and Rex Black. And in that book, it's called Foundations of Software Testing, ISTQB. And in that book, I think on the sixth or the seventh page, if I remember correctly, it talks about testing principles. Now, that is one of the first things that is taught to us when we start talking about testing principles. And we just read through it. We sometimes discuss about it in the class. And then somehow we tend to remember it. And we use it uh, sometimes in our discussions, in our arguments, but we don't apply it in our testing day in and day out because it is something like, okay, somebody has told you that brushing is good for your teeth, so you brush your teeth every day without realizing that, okay, it has become a more of a mechanical process. You don't ask, okay, how can I make it better? Is there a different toothbrush that I can use? Can I use an electrical toothbrush, or what else can I do? Is something that we don't question. So in the 50 years that we've been testing, we've gone through a lot of changes, and ever since ISTQB has come up, these seven principles have stayed. They have stuck on, and still till today in 2026, when somebody goes for the ISTQB foundation level certification, they have to read the book, they have to read the principles, they have to answer the questions that are asked in the certification exam. But how many times have you seen somebody questioning the principles themselves? Do they hold good in 2026? Should it be seven principles, first of all? Why not eight? Why not six? Why not five? Are they valid? Do they make sense? How many times have we asked these questions? We generally don't. As testers, we must understand something. Okay. Testing itself is thinking and asking questions. So when you are testing something, you are actually asking questions about the product. Does it work? What if something goes wrong? What if I try to do things through a different approach? What if I take a different path? These are the questions that you're constantly asking to your software. So if you are asking questions to your software, why are you not questioning the principles that are taught? It's something that I want to stress upon through this presentation. Now, I want to give a disclaimer, and I've not put this on the slide on purpose. That today I'm going to tell you some things which you may hear and say, "Hey, what is this guy saying?" Okay, I may challenge some of your basic thinking about testing and what you've learned over the years. And I want you to go back after this presentation and think on those lines and come back or go back to your organizations and ask some hard questions. I mean, to your bosses, to your colleagues, to your clients, maybe, and see how best you can utilize your position as a tester. Because let me tell you this thing up front. As testers, we are in the best ever position we could ever be in this world with AI taking over so much. People are saying that, oh, because of AI, we are going to lose jobs and this and that. Not happening. Not happening. Because somebody will need to test the AI itself, and nobody better than us, right? So keep that in mind and let's get started. So a little more about myself. I know Vamsi gave a detailed introduction, but still I'd like to put in a few things. I have spent about 27 years in testing. I talk about testing, quality engineering, agile leadership, and now, of course, AI. I am more concerned about building testing culture. I do not want people to be that robotic tester who just goes in, reads requirements, writes test cases, executes test cases. If there's an opportunity, automates them, and then watches all the fun sitting on the sideline. No, I don't want that. I want to enable testers with the strength that they have, the ability to think, build their intellectual capital, and motivate them to do better, to innovate in case of testing. Okay, I'm an international speaker. I deliver keynotes at international conferences. And very recently, I was at the Eurostar Software Testing Conference, where I delivered a talk on AI. And this year, I won the European Testing Excellence Award and the Best Paper Award, which was supporting my talk. So yeah, these are a couple of my achievements. I'm sure that if I can do it, many of you can also do it. So if you've not started talking in meetups or conferences, please take that up. Okay, put across your perspective and uh, shine the light on the craft. That's it, right? Okay, now let's talk about principles. So I have a basic problem with principles. Over the years, we have seen testing principles being there, written, spoken about. They have given us a structure to the testing, and we believe that they have helped us move forward. They've offered legitimacy to the craft, is what we believe. Okay, because of the principles, there is a guideline and things like that. But my problem is when there is no challenge to the principle. Why are we not asking any question? Are all the principles that we've learned over the years still valid? Is a question that you should ask. Are those the only guidelines or rules that we have? That is a question that we should ask. If we are not asking those questions, I don't think we are doing enough. Now, one of the principles, that is, I think the sixth principle out of the seven traditional software testing principles, says testing is context dependent. Interestingly, the word context is the most misused terminology or abused terminology in the world. So much so that with AI, we have seen a proliferation of the term context being abused very badly. Having said that, one must remember that context is the most important thing when it comes to a test. A test step, a test case, a test process, which may work for me, may not work for you because it depends on the context. My context will be different from your context. So, obviously, what applies to you may not apply to me. Okay, so many times I have seen a lot of leaders saying, oh, you know what? In that company, they have used automation and they've been so successful. Let's do the same thing with us. Now, people don't realize that not only are the products different, the contexts are completely different. The context of testing an app like Facebook versus the context of testing the app for a bank or for a pacemaker software, is completely different. So what applies in a social media context may not apply in the healthcare context and will not apply. It will be completely different. Yes, certain ground rules might remain the same. However, the kind of test that you do, the approach that you take is going to be completely different. Okay, so there can be principles that may sound really, really logical, they can sound absolutely wise, but if the setting or the context is wrong, it'll be completely useless. And instead of helping the team, it will start harming the team. You will see that the productivity drops because you're using a principle out of context. So remember the fact that context remains your baseline, your key concept. Okay. So, why am I bringing this up after so many years? Well, to be very honest, I have been talking about this for many years now. And everywhere I go, I ask them. So I'm a consultant. I go to customers and I solve their testing problems, testing challenges, help them with their automation, help them with their non functional testing. But every time I ask with a very basic question. Okay, what is your test policy? What is your test approach? What kind of documentation do you have? Are you following any certain fixed set of rules? And a lot of times in the conversations, testing principles come up. But we see that modern software delivery is no longer the same. Earlier, we could relax pretty much after a release. But now, in a lot of cases, the real testing or the real journey of the product begins once it is released. And that is why you see concepts like shift right. And, you heard it from the previous speaker. He gave a wonderful example, a very nice case studies. Great example. I absolutely loved the talk about shifting right and doing shift left as well as shift right. And it made complete sense. And that is what the world needs, that you should understand that with situation over the years, the testing or the way of thinking about testing has changed. And that is where this conversation matters. We saw things change dramatically with the advent of Agile at the start of the term. In fact, let me go further back. So I started my career in 1999. Some of you may not have been born even then, I guess. Okay, so yeah, I am old. That's okay, but but that time in 1999 when we started testing, people started whispering about something called automation. Okay, automation was coming up. There were tool vendors who were trying to sell their tools, and to sell their tools well enough, they created a term called manual testing. Okay, until that time, there was no classification as manual or automation or anything. It is a term that was created by the vendors of the automation tools because they wanted to sell it and they wanted to compare it with something and saying, okay, manual is slow, automation is fast, and our tool gets you there faster. Excellent. But what happens with that kind of a situation is that term, manual testing, has stuck with the industry up till now. And till today, people are not able to get rid of that terminology because people don't understand that, no, that is not the right way of thinking. They don't understand the fact that You cannot apply concepts like manual in the testing industry because it is a knowledge industry. When it comes to knowledge, everything involves the brain, it involves the human. So there is no manual, or even when you're doing automation, there is a lot of brain that is you're applying, you're writing the code yourself. So isn't that manual coding? But we use that term? No, we don't. Then why specifically with this? So we saw all of that happening at that point of time. Then a few years later, in 2001, when the Agile Manifesto came up, people suddenly started talking about Agile. They said, oh, this is going to solve my problem. What we are going to do is have testing as a part of the development team. Excellent. But how is it solving the problem? The testers suddenly started feeling, oh, you know what? I am not being valued. Then DevOps came along. And DevOps, when it came along, it started talking about shift left. So, okay, this is going to solve the testing problem because we are going to shift testing sooner. Well, bugs still kept coming. Then, we saw the advent of cloud, we saw the advent of low code, no code. People started saying, oh, with low code, no code, anybody can write tests, but did that actually change the testing landscape? No. Today, with AI, there is so much uncertainty. Okay, people are doing vibe coding and building apps, and people are saying, oh, you know what? I have an AI agent which can test your AI agent. Excellent if your AI agent can do that. But the question I would ask is, can your AI agent test itself? And in a lot of cases, trust me, guys, the answer is no, because they have used traditional testing methods to use it. And that is where this conversation becomes even more important. What was true many years ago, does it still apply? Is a question that I want to ask. Now, let's go back and revisit the 7 testing principles that we learned through our ISTQB books. Testing shows presence of defects. Perhaps, yes. Okay, without testing also you can see defects. Well, exhaustive testing is impossible, which is true, definitely. Early testing saves time and money, may or may not be true. Sometimes you need to test late in the game. So you cannot always say that this is always true. Defects cluster together, yes, in a lot of cases. In a lot of cases, no. When you get intermittent bugs, what happens to them? So this may apply, this may not apply. Pesticide paradox, I think it was one of the most brilliant things that somebody spoke about. And well, I see that I've listed only 6 here. There is a 7th one, which is the absence of error fallacy. I'll come to that. So I should have tested this slide. But then, anyways, yeah, so pesticide paradox becomes important because after a point, your test cases become stale and you don't find any bugs using the same test cases over and over again, which is kind of true. But then, the concept of test cases itself is flawed. In not all situations do you actually need test cases. What you need is a simple test idea, and you can execute using that. You don't need to write elaborate test cases and spend time or waste time in researching about your test oracles and stuff like that. Then testing is context dependent, like I said earlier. And the final one, which I have not listed here, is absence of error fallacy, where, if you think that there is no error, it doesn't mean that there is actually no error. Okay, it may be there in some part of the application which you have not tested. Just because you think that there is no error, doesn't mean that the error is absent. So, what did these principles get right? First of all, is they gave structure. Okay, they gave a certain structure to the way people started thinking about testing. They made the discipline explainable, and people started thinking about risks. So risk-based testing was introduced based on these testing principles very early in the game. However, risk-based testing has also taken shape and has evolved over the years, and I can do a whole different talk on risk-based testing and how it is being used in the agile context. In fact, I think a couple of days ago, I wrote a post on LinkedIn as to one of the evolutions that has happened in the AI world, with a risk agent being built as one of the AI solutions for testing by one of my friends here in Germany. Uh, so these principles have been a guideline. These principles have been a baseline for over the years, and as we could see, it also has become options in the quiz. So here is where I kind of challenge the old testing principles. Early testing, like I said, is not always valuable, because if the learning comes later in the game, so we have to test later. Defect detection alone is too narrow for model product work. It doesn't help us if you're only focused on defect detection. Sometimes you should focus on risks. Sometimes you should focus on fixing the process. Sometimes you should focus on fixing the knowledge gaps. In a lot of root cause analysis that is done after bugs are found in production, it is seen that there was a gap in the thinking of the development team versus the thinking of the testing team, and that is why the bug has leaked. So the thinking needs to be fixed there, not the test or not the product. Okay, so similarly, there are a lot of ways in which you can actually challenge uh, the thought process. Now, an interesting point that I want to make here is requirements focused thinking. Now, this is something that I want to talk about in greater detail, because what happens in a lot of cases is people get their requirements and they jump on and start writing test cases based on their requirements. A lot of people will say, oh, so what's wrong with that? The thing that is wrong there is that the part of thinking is completely skipped. When you have requirements, how many times you as testers have gone back and asked, are these requirements complete? First. Second question, are these requirements accurate enough? Third question, are these requirements valid, or is the user wanting something else? Do these requirements make sense? If there is a requirement change, does it cause an impact on the other requirements that you have? What are the implied requirements? Sometimes not every requirement is written. There are implicit requirements. And of course, a lot of stuff is explicitly said. So that thinking has to come as a part of the process. You as a tester have to constantly be working on that. A lot of times we say, until the requirements are stable, automation cannot begin. This was a very popular theory in automation up till a few years ago. And I don't know, some people still believe that. What if there are no requirements? Will you not test? In a lot of situations, you don't get requirements. Can you still not test? I find it ambiguous when people say, no, I need requirements for testing. No, you don't. Always you don't. Sometimes you just need the product and the capacity to think. But we are not asking those kind of questions. And that is what worries me as a tester today. When I look at people who feel that they are stuck because they can't think beyond the traditional ways of thinking. We are so used to thinking about the terms and abbreviations that is thrown at us. One of the most popular abbreviations that we use in testing is QA. And I absolutely love the way people have abused this QA term. If you ask, a lot of people will say QA means quality assurance. My question is, can you really, 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 as a tester, assure quality? And I'll give you my answer also. You cannot. The only person or the only people who can assure quality is the people who are actually building the product. Now, I also saw, and I also keep on seeing that people argue that, quality is everyone's responsibility. Well, I disagree. Quality assurance is everyone's responsibility, is the more appropriate term. It is not a one person or a one team job. So whenever I hear about terms like assurance, I just my head just starts spinning. And that is why when you talk about structured assurance, teams got rebranded. People started saying, oh, you know what, we are the digital assurance team. Oh, we are the quality assurance team. I'm like, wait a minute, guys, think about it. Are you really, really going to assure quality? And if yes, how are you going to do that? Who's going to give the guarantee that, okay, after I have tested, this is going to work? At any point, can you do that? Just think about it very deeply. People talk about sign off. Are we the sign off authority? No. Businesses, stakeholders are the sign off authority. So why should testers be held responsible for a sign off? The very basic definition of testing has gone out of the window. If you ask, okay, why do you test? I test to find defects and to ensure that the product works. No, you don't. No, you don't. Your job is to find out information about the product. And based on that information, the stakeholders will decide. They will take an informed decision whether you want to progress further or not. In your journey of finding information, you will find pieces that are anomalous compared to the requirements, which you classify as defects. So defects are a byproduct of your testing effort, not the direct product of your testing effort. In the very beginning, I gave a disclaimer that I'm going to say things which is going to shake some of you, and these are the kind of things. Because we don't think enough about the craft. We are like, oh, we got a job in testing. It's going to feed me for the years to come. It's going to give me a salary at the end of the month. That is all we are focused on. But are we thinking really deeply about the craft is something that I want to talk about. Okay, I want to emphasize on the fact that there is a lot that is happening in the industry today. So start thinking and start evolving your thinking. Now, because of the questions that started getting asked, some people started thinking about evolution in the testing principles. Somebody said, when we talk about products, when we talk about building products, we must bring the product to a state where the quality of the product is great when it is being shipped. So it started getting classified as shippable quality. So people started working towards improving the shippable quality of the product. Even Agile says that as long as you have a working software, we are good at the end of the first sprint. But is it shippable? It might be working, but is it shippable is a question that people started asking. Is the quality good enough? Now, again, quality, the definitions may vary, but quality is very simply something of value to the stakeholders who actually matter. Okay, what is of good quality to Sagar may not be of good quality to me. What is of great quality to me, Vamsi may completely disagree and say, no, this is a rubbish product, right? So the context of quality changes from person to person, from situation to situation, and that is why context again becomes very important, right? So a few years ago, two gentlemen, Alan Page and Brent Jensen, thought really hard about this and came up with the idea of this modern 7 testing principles. Okay, and again, I have listed only 6, but this time it is deliberate because I want you to go and research. Okay, because if I give all 7, people will look at these slides and forget about it. I want you guys to go and Google what are the modern software testing principles. Think about it, start conversing about it. Okay. And these seven testing principles that have changed, they talk about focusing on the quality of business. They want to give importance to business outcomes. They want to improve the way of thinking by going lean. They want to focus on continuous improvement, and they want to impact the quality culture and ultimately improve the shippable quality of the product. Okay. Now, I have not given you a direct link because, again, people will stick to the slide. They will not do any further research. If you go to Google and just ask modern software testing principles, it will take you to the A/B testing podcast link. And that will give you the seven testing principles. You can read enough about it. You can listen to the podcast from Alan and Brent. It is an excellent podcast. It is called A/B Testing Podcast. Okay. A for Alan and B for Brent. That's how they came up with the name. Not it is not the A/B testing that you do in production. That's different. Okay, that is a comparative testing you do between two builds when you apply the principles of shift right. That is different, and this A/B testing is different. Okay, so you have to be careful about that. Now, what did these guys get right? They moved the aspect of thinking from defect reporting to actually think about the product's entire journey that is happening. Okay, and they connected the outcome to business improvement. They did not say, oh, you know what, I have found defects, my job is done. No, they recognize the actual bottlenecks when it comes to quality problems. Now, a lot of businesses try to dismiss saying testing itself is the bottleneck, but you have to be smart enough to understand that no, something else is causing testing to go a little longer, to go a little slow, which is causing to be a bottleneck. So this culture of improving has to happen, and it gives, most importantly, testers a voice. It gives them the capacity to influence decisions. Now, a few minutes earlier, I said testing is about getting information and giving it to the stakeholders, which means that the testers need to have a voice. These modern testing principles give you that voice. However, having said that, there is enough room for the modern testing principles to be misread or misinterpreted by businesses. Now, when I say improving the business, if you cannot showcase the impact properly, people will not understand. It will not be seen. Okay, people will say, oh, you know what? I am not doing any independent verification and validation. So where is the safety net? Okay, my decision may be influenced by somebody else. That is the question that they may ask. Again, you have to clarify what is your priority, what is your focus, what is your goal, what are what are you trying to achieve, and then go ahead and produce your results. The customer always judges quality, that's true. But in a lot of cases, they forget about safety, security, ethics. It becomes absolutely irrelevant to them. Then there is a lot of data dependency that happens. And there is a word that keeps coming, confidence. Well, guys, testing does not give you confidence. Fixing those defects will give you the confidence. Testing only gives you information. So if somebody is telling you that I have tested and I'm confident, no, you're not, because there is absence of error fallacy from the basic testing principles. If you have not tested something completely because exhaust testing is not possible, how are you so confident that there are no bugs remaining in the system? So I can actually challenge your confidence, right? So the thing is that it is not old versus new. It is about old existing with the new principles. And that is what I want to emphasize here. That while we focus on the modern testing principles, I do not think that the old testing principles or the traditional testing principles should be ignored. There is enough room for us to work on what is common between the testing principles and what are the best cases that we can have from them. Again, another thing that might shock you, I do not believe in best practices. There are no best practices. The word best practices actually, I find it completely wrong. It is always good practices that work the best in your context, right? So when you are talking about combining the power of the traditional testing principles and the modern testing principles, they should be the principles that work the best in your context. See how many times I'm using the word context, because it is the most important thing. So let's do a comparison. Okay, traditional software testing principles, it focus on the nature of testing. What kind of testing you're basically doing. Whereas the modern testing principles, they focus on continuous improvement, they focus on delivery. Traditional testing thing, challenge the this thing about exhaustive testing. Modern testing doesn't even look at that. It only focuses on how it is going to improve. Improvement is the main key. Traditional testing principles was used because testers didn't have a voice. They wanted to have a structure. They wanted to say, okay, something needs credibility. So it helped us establishing that credibility. Whereas the modern testing principles, it actually gives the testers a voice, the ability to portray what they're actually thinking. So I've taken a couple of examples. I'm going to just skim through these. One is early testing. So yeah, early testing valuable in a lot of cases. Sometimes you need to wait. Sometimes your testing needs to wait till the product goes into production, because you want to see how the real users interact. What is the usage pattern? What are the user dynamics? How does your product behave when 5,000 users actually come in live and do it? I mean, you can do enough simulation using different tools, but when the real users arrive and when they choose paths which you didn't even think about, that's when the challenges come out. Okay, so early testing may not always be a useful thing. Then testing is context dependent. Now, this one, okay, like I said, I mean, we may borrow the ideas from some place, and say, oh, you know what? They use automation, they used ABC metrics, they use these fancy set of tools. Let us use them, and we'll also be successful. Come on, your context is completely different. So think about that. Just don't get carried away by the bandwagon bias that is there. That everybody wants to do the same thing because company A says that, oh, AI has made us successful. Company B need not use that just because somebody else is successful. Now, bottlenecks are quality problems. Why do I say that? Now, we can have a lot of bottlenecks in the form of cost pressure, in the form of delays, in the form of reduced testing effort, because in a lot of cases testing effort gets cut. More days consumed in development and only a few days in the sprint given to testing. Then poor product decisions, certain features which make absolutely no sense, they are prioritized. Those are the actual quality bottlenecks. You can't simply sit and say, but oh, you know what? Testing is the bottleneck. Now that's something that you've got to challenge. You've got to find out what the real problem is and be vocal about it with enough evidence through your testing. That is something that I wanted to emphasize here. Previously, also I mentioned the customer quickly judges quality. They don't care about safety, they don't care about security, they don't care about performance. What they will look at is the quality that you're delivering to them. And sometimes safety, speed, performance, everything is a part of the quality decision that they're going to make. Okay, so when there are customer facing projects, look at the areas that you're actually looking for. Ask the customer, what is your actual pain point? Am I actually solving your problem with the product? that we are shipping to you? Is a question that you should ask. If your product manager has not asked, you ask, because you have the voice, you have the authority as a tester to ask that question. If you don't have access, then get that access from your leadership and say, you know what, I want to understand what is the customer's pain point, and through our testing, how are we solving it? Because that will help you improve your testing itself, right? So change your focus areas. Now, a lot of people say, you know what, I can blame it on data. My test data was poor, my production data is poor. But you can't always blame data. Okay, data is useful, but it is not innocent. Okay, you can make good use of data, you can make bad use of data, you can use good data, you can use bad data, but you can't always blame things on the data. In a lot of cases, problems are blamed on data. No, it is your process, it is your way of thinking that needs to be challenged. Okay. Make sure that testing is expanded across your ability. Sometimes ask your manager, can you spend a few minutes testing the product yourself or looking at it and give me your feedback? It is of great value if you can ask your product manager to do that. They will say, no, 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 it is your job. And you say 15 minutes or say 5 minutes. Can you come take a look? How do you feel? This is what is happening. Is the product behaving okay? What do you think? You will get a different perspective. And that is why events like bug batches become so important, where the entire team, including sales, marketing, HR, everybody jumps in and just beats up the product. So get the ability to think about testing expanded across your own team. And you as testers are best positioned to do that. Always think about context, build a context matrix, and see how the principles apply there, how the strategy can be changed. Have context absolutely clear. From time to time, audit the principles and see if they still make sense. If they don't make sense, build your own principles based on your experience, based on your requirements, based on your context. Okay. Now, there is one exercise that we normally do is the sacred cow exercise. So pick one principle, ask your team, and decide on one principle which they think that it is absolutely true. Ask in your team if you did exactly the opposite of what is stated in the principle, what will happen? And then see what is the best case, what is the worst case. And then you will always find that there are certain new ideas that come up. Okay, this exercise works very well when you're starting to talk about automation in your case. Okay, when you want to automate, take a feature and ask the opinion. If they think this is complex enough to be automated, or simple enough to be automated, or complex enough not to be automated, ask questions. You will get diverse perspectives. When you do enough brainstorming, you will find out. And it will help you in your feasibility analysis. It will help you in your risk analysis. Okay, so this is a good exercise to do, very small, very simple. So it's something that you can actually do it when you go back to your work on Monday. Now, the traditional, like I said, the traditional principles, they hold good sometimes. The modern principles, they hold good sometimes. You are the best judge which one is working when and which one supports you better under what circumstances. So don't say, okay, only the traditional testing principles work well for me. Sometimes visit the modern testing principles, have them on the wall, discuss enough, and say, okay, I'm going to pick 2 from here, 3 from here, or whatever combination, or all 14. I'm going to create my own mashup, because that provides me the best music for my product. Go for it. Okay. The real skill is in discernment. Discernment is actually the ability to not memorize stuff, but actually thinking about it and interpreting them. Okay, knowing what works best in your context, knowing what works best for your organization, for your product. So develop that skill. Okay, just thinking about writing test cases, improving automation, writing better code, how to use AI. Nowadays, the new problem is how to save tokens. Get out of that mindset. Start thinking about how can I make my life easier? How can I do better in my job? And with that, I would like to conclude and take any questions that are there for me.
Yeah, thank you, Brijesh. Thank you for the really thought-provoking session which we had now. So, from your session, the idea that principles are tools rather than universal truths is both powerful and liberating. The future of testing isn't better dogma, but it's better judgment. So,
Yep.
thank for sharing those insights with us. So, as you said, like let's move on to the questions now. So, in the meantime, maybe Sagar, you can display the feedback slide. I'll-
Yeah, I also wanted to mention that QR codes are quite popular in India. So I have one. Don't worry, you're not going to pay anything using this QR code. You're only going to go to my LinkedIn and connect with me. So you can use this QR code if you want to connect with me. And if you have any questions, I'm open for any discussion, debate, anything.
Yeah. Thank you, Brijesh. Thank you for that. So let's move on to the questions. So question one comes from Kamakshi, which is how should teams view bugs found after release? Are there any reflection of the tester's performance, or are they more indicative of the overall quality assurance and development process?
Well, bugs are indicative of the understanding of the entire team. Okay. More often than not, you will see that bugs are an indicator of your testing process, of your testing philosophy, of the commonalities between the dev and the engineering teams and the quality teams. Sometimes there are miscommunications that happen, bugs indicate that. So holding them against testers is honestly a very wrong thing to do, in my opinion. Okay, if you are judging your testers based on the number of bugs that are found by them or missed by them, then you are doing the wrong thing, because that's a completely wrong yardstick. Okay, testers miss bugs because of multitude of reasons. First of all, how many times we have seen testing getting squeezed because of release pressure, the time pressure. Okay, you don't get enough time to test, you don't get enough resources to test, you don't get the right environment where you're testing, right? So there may be multiple challenges that may occur, so you can't always blame the tester for that. Okay, yeah, I hope Kamakshi have answered your question.
Yeah, thanks, Brijesh.
Yes.
Yeah, thank you. Thank you. So we'll move on to the next question. Sorry. So, what are the industry best practices for selecting test devices for mobile applications? Given that testing on every device isn't feasible, how can QA teams minimize the risk of device specific bugs reaching production?
Okay, just a short while ago, I said I don't like the term best practices. So I'll reiterate that it is good practice that works in your context. Okay, so to answer your question specifically on choosing mobile devices, well, again, on the context of your product, okay, have you identified your user base? Have you identified your user usage patterns? Okay, where are most of your customers located? If most of your customers are located in the or users are located in the US market has a predominance of Apple phones, iPhones, right? Whereas if you come to a country like India, if you're more users in India than Android phones, outnumber iPhones. So the choice of device will first of all depend on that. Secondly, there are many cloud providers. They give you access to mobile devices. Use them, again, depending on your context, depending on your usage patterns. So before getting into deciding what devices, establish the user personas, establish the usage patterns, and only then take a decision on what you want. And the cloud providers like Sauce Labs or you know Browser Stack or TestMu, they can offer you the platforms as far as your devices are concerned. I hope I have answered that question.
Thank you, Brijesh. So maybe we'll move on to the next question. So most of the projects now they are integrating the AI tools into the development pipeline. So how do you see the role of a tester evolving in this AI era?
Excellent question. You know, in very early when ChatGPT came and then other tools came, in one of the podcasts called The Diary of a CEO, a couple of leaders they announced that testing is the first job that is going to be taken away by AI. That was said. It's been 3 years since that podcast came out, and in these 3 years, we have seen that the number of testers needed has increased. What happened there? The judgment of the leadership went completely wrong. So in the AI era, when more and more teams are integrating AI into their development pipeline, the need for testers increases, because remember that at the end of the day, somebody will need to test the AI. Okay, you cannot have an untested AI in your system. Okay, so testers will be needed. However, their skills are changing. You cannot rely on traditional testing skills. Just study the ISTQB book and feel that you are a good enough testers. No, you have to develop more practical skills. You have to understand the architecture of the applications better. You have to understand what the AI is doing, how it is behaving. Okay, you have to go behind the scenes. You have to focus on learning code, even though a lot of applications are getting written using vibe coding. I emphasize on the need to understand code, because if you do that, you are able to talk to developers and architects and other engineering members much better. Okay, so your skills will change. Your skills will improve, will need to evolve. As a tester, your role is not going away, but you are just evolving. So it's a time for a modern tester, I would say.
Yeah, thank you, Brijesh. So when go to the next question, so what specific skills or responsibilities should we as a tester focus on to add the most value to the team?
First and foremost, most important, be curious. Okay, if you are not curious enough, then you are not a good tester. It's as simple as that. You have to have the curiosity. And the second most important skill that not a lot of people talk about is the ability to ask questions. A lot of testers do not ask questions, not in the interview, not during their testing. They simply do what is instructed. Oh, I have requirements from there. I go to test cases, I execute those test cases, I'm done. No, if you don't ask questions, you are not testing. You should be asking questions all the time. Why is this happening? Why have you developed it in this way? Why only choose this tech stack? Have you ever questioned? Have you gone to the engineering manager and asked, why are you choosing this tech stack? In a lot of cases, you will find that the answer is because it is cheap. The investment is less. That is why I'm using these tools. But are those tools going to help you? Then the next question that you ask, okay, I am building automation, I'm working on automation. Is my strategy, have you included my strategy as a part of your product engineering strategy? In a lot of cases, no, it doesn't happen. In a lot of companies, automation projects are lying outside of the actual project, and it's a separate project that is running. So you are solving your problem instead of solving the customer's problem. Automation has to be integrated within the product engineering, right? So developers and testers need to work on automation together. It's not a responsibility that, okay, you hire automation tester or an SDET and nowadays an AI vibe coder or somebody and say, okay, you know what, you build automation for me. It doesn't work like that. You have to change the thinking, you have to change the skill set, you have to evolve. That's the thing.
Yeah. Thank you, Brijesh. Thank you for that. So maybe we'll take one more question, keeping time in mind. So how should QA engineers handle bugs reported by users after a product has been released? What is the standard industry approach to investigating, prioritizing, and preventing these issues?
Yeah, so the industry standard or the best way of doing it is to do a root cause analysis. What happens traditionally is testers get blamed, saying, "How did you miss the bug?" But that is completely wrong. What the industry should rather be doing, and it is being done in a lot of cases, in my experience, is that you should be doing a root cause analysis. There are multiple ways of doing root cause analysis. If you go to my LinkedIn and look for the articles that I have written an article about 9 different ways of doing an RCA. Choose one of those techniques. Of course, there are more, but I chose those 9 because I absolutely love those 9. I've used all of them, and I use all of them alternatively. So, you do a root cause analysis, find out where is the gap, and then try to address that gap so that once the gap is addressed, the bug will automatically get addressed. Okay. In doing this whole exercise, in doing the root cause analysis, finding out, just don't do it in silo. That is only the testing team sitting and doing this exercise. You involve everybody, every stakeholder, business leaders, product, engineering, everybody should be involved because a bug in the product is everybody's responsibility. Quality is not everybody's responsibility. The production bug is everybody's responsibility. Okay. So, yeah, that's my answer.
Yeah. So maybe I'll take one more question. This is from Nilesh. The white code, who will be responsible for the code as a person who developed may not be aware in that case who should held responsible or accountable. Another debate I see when QA is not getting voiced as no representation in engineer team as a lead. What's your view on this?
Okay. So first of all, if your question is about vibe coding, well, AI is not accountable. The human behind that AI is accountable. So whoever took the decision of using a certain tool, any business leader, any stakeholder, they are the person who is accountable for it. Secondly, about voicing, yes, you're absolutely right. In industry, there are a lot of companies which don't give voices to testers, and that is why my plea through this presentation was that you start talking more, participating more. You ask the right questions and ask them, okay, what is in it for me? For example, when the requirements come, okay, ask them, are they really coming from the product owner or not? If the product owner is sitting in a requirements gathering meeting, as a tester, you or your representative should be sitting in that meeting alongside the product owner. He should not be doing this alone. Okay, you cannot have a product built on a developer's version of the requirements, which happens in a lot of cases. So show your presence, ask those questions, be curious and ask questions, guys. That is the mantra. Okay, the moment you stop asking questions, people will stop valuing you. Okay, we wait until appraisal time and say, okay, we'll have one discussion with the manager and they will increase our salary. It doesn't happen like that. Throughout the year, you have to eat their head, right? Only then they will say, okay, you know what, I remember you told me, I'll increase your salary. At the end of the day, if you go and ask, they'll say, no, they'll give some excuse. Yeah. So I could not think of a better example.
Yeah, thank you, Brijesh. Thank you.
Thank you so much, Vamsi. Thank you.
Yeah.
Thank you. And thank you, Sagar, for giving me the opportunity. It was great talking here. I have been following the other talks as well. And really great conference. Keep it up, guys. Wonderfully done.
Thanks.
Yeah.
Thanks, Brijesh.